All right, y'all, here is part 2 of 5.4a. Part 2 is still going to use double angle identities and half angle identities and maybe some power reducing identities. Probably not, those ones we don't use as much. It's just a continuation of what we did yesterday. So we're going to start off with example 4. It says use a double or half angle identity to find the exact value. Problem A. The sine of theta equals -3/5 and pi is less than theta is less than 3 pi over 2. Find the tangent of 2 theta. Okay, so let's break down what we were given. This part right here tells us that we are talking about quadrant 3. Because here's pi and here's 3 pi over 2. So we have a triangle in quadrant 3. And then the sine fraction tells us the opposite and also the hypotenuse. So the opposite here is -3 and the hypotenuse is 5. Right, the opposite's going to get the negative because negative legs. The hypotenuse is always positive. Okay, so then it says that we need to find the tangent of 2 theta. So we're going to need the double angle identity for tangent, which is this, 2 tan u over 1 minus tangent squared u. And of course, I used theta instead of u because this problem uses theta. Okay, so we are going to plug into this formula that I just wrote here in green. We're going to figure out what the tangent of this particular theta is. In order to do that, we need the opposite and the adjacent because that's tangent. So we're going to need to figure out how long that remaining leg is. And we do that with the Pythagorean theorem. A squared plus b squared equals c squared. So in this case, 25 minus 9 is 16, so b's 4, -4, because it's going that way. So the tangent then is -3 over -4, which is 3/4. So on top, I'm going to have 2 times 3/4, and on the bottom, 1 minus 3/4 squared. So on the bottom, 3/4 squared is 9/16. Up on the top, that 2 has a 1 underneath it, right? So the numerator is 6 and the denominator is 4. So let's just keep on doing the arithmetic to simplify this out. So the top is now going to be 3/2. The bottom, I have to get common denominators to add those together. So 1 is the same thing as 16/16. 16/16 minus 9/16 is 7/16. And dividing by a fraction is the same thing as multiplying by its reciprocal. So that reduces right there. So I get 24, because that's 3 times 8, over 7. And the answer is positive, and it makes sense that the answer is positive because it's asking me about the tangent. Right, tangent is positive here. B. The cotangent of theta equals 3√7 over 7, and 0 degrees is less than theta is less than 90 degrees. Find the sine of theta over 2. Okay, so this is telling us quadrant 1. The cotangent fraction tells us the adjacent over the opposite, except that this 3 root 7 over 7 used to be 3 over root 7, so I'm going to think of it like that, right? I'm going to unrationalize it. So I have an adjacent of 3 and an opposite of root 7. So let's just find that hypotenuse, huh? 3 squared plus the square root of 7 squared equals c squared. So 9 plus 7 equals c squared. That's 16. So c is 4. Okay, so we want to find the sine of theta over 2. So right now we have a triangle that's in quadrant 1, and we are going to find the sine of that angle cut in half. If we take any angle measure in quadrant 1 and cut it in half, it's still going to be in quadrant 1. And the reason that's important is because the sine half angle identity has a plus or minus in it. So again, I'm just going to scroll up here to the top. Ooh, it's still highlighted from the last lesson. So plus or minus the square root of 1 minus cosine of the angle over 2. So we're looking right here and we want to decide, is it plus or is it minus? So half of any quadrant 1 angle is in quadrant 1, where sine is positive. So that means we know that we're going to choose the positive. So we just have positive square root of 1 minus. The cosine of this angle is the adjacent over the hypotenuse, so it's 3/4 all over 2, which is, that 1 is the same thing as 4/4. So that's 1/4 divided by 2 in there. Dividing by 2 is the same thing as multiplying by 1/2, so now we're at the square root of 1/8, which is the square root of 1 over the square root of 8. Square root of 1 is 1. I can't leave like a root in the denominator, so you can make it be 2 root 2 right now, or you can leave it as the square root of 8 and then reduce at the end. So I'm going to rationalize, multiply top and bottom by the square root of 8. So now I'm at root 8 over 8. Root 8 is 2 root 2 all over 8. So that reduces to the square root of 2 over 4. So it's the same stuff as the last lesson. It's just in a different context because now you've got triangles to think about. All right, that's the last part of 5.4.